Hi students, I want to show you how to complete this Exploring Gravity Lab from PHET, P-H-E-T, which is from Colorado University. So this lab has you explore gravity using a simulation that they have online. And you start out reading this little background information that Jasmine and Emily were learning about force in class. They learned that a force was either a push or a pull. That is really important for you to remember. And that Emily wondered if gravity was a force. She knew that when she dropped her book, that it was pulled down to the ground, and Jasmine knew the moon had less gravity than the earth, but she wasn't sure why. So you're gonna start by circling all of the statements that you agree with. So we're gonna go through some of those as just some of the background information. So the first statement says, gravity depends on the materials of the objects. Gravity depends on the material of the object. That actually is, well, what do you think it is? This says circle or check the circle containing the statement you agree with, but more than one of these is going to be correct. So gravity depends on the material of the objects. And that answer is actually true. If an object is made out of, for instance, an orange or something like that, so it's a spherical shape, but it's full of a liquid, it's going to have a lot more mass than if it's a ball like this, about the same size as an orange, but hollow inside. So it does matter what material it's made out of. The second one says, gravity is not a force because it cannot move objects. I hope you know that gravity can move objects. For example, if I have this like hacky sack and I drop it, it definitely falls, so gravity can move objects. The next one says gravity is a force because a force is a push or a pull. And that is true. Gravity is a force, and a force is something that pushes or pulls something else. The next two I'm going to make you figure out, and you check those. Okay. So this is something that you need to understand the next part. A variable is any factor that can be changed or controlled. And an independent variable is something that's changed by the scientist. So what's being tested or manipulated. So in this simulation, we are going to be manipulating basically the mass of the object. We're going to be manipulating that, okay? The independent variable, so the size of the object, the mass of the object is what we're going to be manipulating. That's the independent variable. The dependent variable is what's being observed or measured, which in this simulation is going to be the resultant force on that object. So the independent variable is going to be the mass of the object, and the dependent variable is going to be the force or how much it moved. How much pull is on it because of its size. There's a couple things you need to know about gravity. First of all, gravity acts on all things, anything that has mass. So, but the more mass an object has, the more gravity is going to be able to act on it. So this like hollow, like little ping pong ball is not going to have as much gravity acting on it as this tennis ball. Not just because the tennis ball is larger, but also because the tennis ball has more matter and has like, it's more dense. I want to show you this little miniature, beach ball. So this little miniature beach ball, as you can guess, it's filled with air, okay? So this little miniature beach ball has less mass than this tennis ball. So gravity will actually pull on the tennis ball more. And the gravity, like every object actually has gravity. You have gravity, your pencil has gravity, your paper has gravity, but the gravity amount is so small because it's such a small object that we don't suck things to us or to each other. But this tennis ball is going to have more gravity than this tiny beach ball because it has more mass. Okay. Also, for gravity, the closer two objects are together, the more they will pull on each other. So if these two objects are further apart, they're not going to pull on each other as hard. The gravitational force isn't as strong. But when these objects are closer together, they have more gravity and more pull on each other. Okay, so you're going to get familiar with this simulation by basically moving these objects closer and further apart. And you see as they get closer together, what happens to the people pulling on them? They're like leaning way back trying to separate them. But when they're further apart, they're not leaning as much, right? But then when they get closer, watch, they start to really pull on each other. And you can see these arrows, which are indicating the force, also get a lot longer, meaning the force is larger. So you can see when they're not as close together, these arrows are smaller, indicating that they're not as close, so the force isn't as strong. That's going to be a question in your lab. Okay, so number 1 on the lab says circle the different variables that can be found in this simulation. Okay, can we change the distance between the figures? Can we change the distance between these guys? I think that's a solid yes. Can we change the force? Here's the force, and here's the numbers. Let's watch and see if we can change those. Looks like yes. Can we change the strength of these guys? How strong our little stick figures are? Is there a way to alter their muscles? That would be a no. Then I'm going to have you answer the last 3 and decide if we can change those. What do you think the size of the arrows at the top represent? If you're not sure, rewind this video about a minute. We just talked about it. These are the force arrows. So look up what the size of the arrows mean. Okay. So here you're just going to experiment a little bit. You are going to pick a variable to manipulate, the independent variable, and summarize what happened in the table below. So the manipulated variable in this first one, we'll do it together. Let's say, so right here as our mass, let's change this guy's mass to 500. And I can get it to about, by moving this, I can get it to about 505. But then to get it exactly 500, I can use these tab over arrows and get it exactly on 500. So this guy's mass, the blue mass, is 500. So let's change this one to, let's say 250. And I got it to 266, so now I'm just gonna tab down to 250. Okay. So if my manipulated variable is making the mass 500 and 250, now I'm going to change the distance and see what I get. I'm going to change the distance. So we're going to say here the distance is maybe about 10. And we'll start about right there. So the force on these two was listed up here. Now it's listed as 0.00000084569. You can go ahead and list that as your force over here. But if you'd like to list it in scientific notation and not write all those zeros, you can just move this decimal point and count how many numbers were behind the 0 before you got to that 8. And we had 1, 2, 3, 4, 5, 6, 7, and we're gonna put a decimal behind the 8. So 8, I would list that as 8.4569 times 10 to the negative, because it was behind the decimal point, to the negative 8. And my mass was 500 kilograms on one ball and 250 kilograms on the other ball, with a distance of 10 meters. The whole thing is in meters. So they were 10 meters apart. Okay, so I'm gonna write it like that. And I'm gonna write the force, sorry, the force is in newtons. Okay, so that's how I'm gonna write it. If you wanted to, you could also draw all the zeros. So for example, you could have 0.000, and you could draw it just the way it is. If you do not want to try to figure out the scientific notation, this would be acceptable as well. So you can play around with that and fill out that one. And then you're going to answer a few questions about gravity here. So, is gravity a force that can be changed? True or false? If you're unsure, you can maybe check the internet. The bigger an object is, the smaller the force of gravity. So the bigger it is, the less gravity? I don't know. I don't think so. You can go and look it up. As one object gets closer to another object, the force of gravity will increase. Decide what you think about that. The sun has greater gravity than Jupiter. And see what you think about that. Okay, here, you are going to, on the first one, circle which pair has more gravity. Would it be these two that have the same size sphere and they're closer together, or these guys that have the same size sphere but they're further apart? If you're not totally sure, practice on your simulation. But I can tell you, look at the way these guys are having to lean. If they're having to lean a lot, then their gravity is probably stronger. And then you're going to explain your answer. You're going to do the same thing here and explain your answer. And then you're going to analyze here. Why do you think Saturn and Jupiter have more moons than other planets in our solar system? So Saturn and Jupiter are really, really, really big. And they have a lot of moons around them. Why would something so big have pulled in like so many moons from outer space? So that's this entire lab. You're gonna get it turned into me for a grade in the Dropbox. Take care.